What if our galaxy is far more dangerous than we ever imagined? While we often think of the Milky Way as a breathtaking expanse of stars, planets, and nebulae, lurking beneath its beauty are forces so powerful they could wipe out entire civilizations in an instant. Scientists have long studied the vast cosmic landscape, but what they've uncovered paints a chilling picture. This isn't just a peaceful neighborhood of celestial bodies, it's a death trap filled with unseen dangers, forces so immense that Earth's very existence hangs by a thread. A galactic minefield. Every night, we look up at the sky, mesmerized by the glowing band of the Milky Way. But what if that seemingly peaceful view hides cosmic killers waiting to strike? Our galaxy is home to supermassive black holes, rogue planets that drift through space unnoticed, and gamma-ray bursts capable of stripping away Earth's atmosphere in seconds. These threats are not just hypothetical, they are real, documented, and closer than we might think. Scientists estimate that our galaxy contains over 100 billion planets, but not all of them are safely orbiting stars. Some roam freely, untethered, moving unpredictably through space. These rogue planets could pass dangerously close to our solar system, altering Earth's orbit and causing catastrophic climate shifts. Then, there are the invisible monsters, black holes. The supermassive black hole at the heart of our galaxy, Sagittarius A*, is constantly pulling in matter, growing in strength, and distorting spacetime itself. A universe of cosmic threats. But black holes and rogue planets aren't the only dangers lurking in the Milky Way. There are gamma-ray bursts, the most powerful explosions known to science. These cosmic death rays are so intense that a single burst could devastate Earth's ozone layer, leaving us exposed to lethal radiation. Some scientists even speculate that past mass extinctions on Earth could have been caused by these energy bursts, traveling across thousands of light years at the speed of light. Then there's dark matter, the mysterious, unseen force that makes up most of the universe's mass. While we still don't fully understand what it is, researchers suggest that high-energy dark matter interactions could be far more dangerous than we assume. If certain theories hold true, this invisible force could be influencing black hole activity, accelerating the destruction of planetary systems, or even affecting the very fabric of our galaxy. What lies ahead? In this video, we will explore these terrifying cosmic threats in depth. From black holes that swallow entire stars to supernova explosions that could sterilize entire planets, we'll uncover the most frightening realities hidden within our galaxy. Some of these dangers could be affecting us right now, without us even realizing it. Are we truly safe in the Milky Way, or is Earth just another target in a galaxy full of destruction? Stay with us as we reveal the deadliest forces lurking in our cosmic backyard and uncover whether our galaxy is a death trap waiting to spring its ultimate surprise. The Milky Way's most lethal residents, supermassive black hole Sagittarius A, the monster at the heart of our galaxy. At the center of the Milky Way lies an immense, invisible force, a cosmic giant with the power to tear apart entire solar systems. This is Sagittarius A supermassive black hole with a mass 4 million times greater than our Sun. It is the most dominant structure in our galaxy's core, sitting 26,500 light-years away in the Sagittarius constellation. Although we cannot see it directly, its presence is undeniable. Scientists have observed stars orbiting it at speeds of over 8,000 kilometers per second, trapped in its relentless gravitational pull. Despite being dormant for now, Sagittarius A is far from harmless. Black holes do not remain silent forever, and if it were to suddenly feed on a large amount of matter, a wandering star, a passing cloud of gas, or even an entire planetary system, it could unleash some of the most energetic radiation in the universe. This event, known as an active galactic nucleus phase, would create a violent quasar, spewing high-energy X-rays and gamma radiation across thousands of light-years. What would happen if Sagittarius A* became active? The results could be catastrophic. Some experts believe that the shockwaves of radiation could disrupt planetary atmospheres, stripping away the protective layers of planets in its vicinity. Earth may seem safely distant, but galactic-scale energy bursts don't recognize boundaries. If Sagittarius A* were to become unstable, its influence could alter the gravitational balance of the Milky Way, sending stars and entire systems on new, unpredictable paths. Rogue black holes, the invisible killers. As terrifying as Sagittarius A* is, it is not the only black hole we should be concerned about. Hidden within the Milky Way are rogue black holes, the silent wanderers of space. Unlike the supermassive black holes found at the centers of galaxies, these stellar mass black holes are much smaller, ranging from just a few to several dozen times the mass of our Sun. Despite their size, they are equally lethal. Rogue black holes are the result of dying stars, colossal explosions that collapse into an infinitely dense singularity, warping the space around them. Some are expelled from their home star systems, drifting unnoticed through interstellar space. The frightening reality is that these black holes could be closer to Earth than we think. They emit no light, making them nearly impossible to detect unless they interact with nearby matter. Scientists estimate that there are millions of these invisible black holes in the Milky Way alone. Imagine if one of these rogue black holes were heading in our direction. Because black holes bend space-time itself, their approach would create subtle distortions in the orbits of planets. Long before reaching us, a rogue black hole could disrupt the orbits of the outer planets, causing gravitational chaos that might eventually affect Earth. The worst-case scenario? A rogue black hole passing close enough to distort Earth's orbit, throwing us into extreme climate changes, or worse, pulling us into its event horizon, where not even light can escape. The closest known black holes to Earth. For decades, scientists believed that the nearest black hole was V616 Monocerotis, also known as AO62000, located just 3,300 light-years away. However, recent discoveries have revealed even closer candidates lurking in the dark. In 2022, astronomers identified Gaia BH1, a black hole just 1,560 light-years from Earth. This discovery shocked the scientific community, proving that black holes can exist much closer than previously thought. But that wasn't the end of the surprises. In 2023, another team of researchers found evidence of an even closer black hole candidate, just 150 light-years away, practically in our cosmic backyard. These discoveries raise unsettling questions. If these black holes remained hidden for so long, how many more could be drifting through the Milky Way, unseen? The answer is unclear, but with advanced telescopes like the James Webb Space Telescope and the Vera C. Rubin Observatory, astronomers are working tirelessly to uncover more of these silent cosmic predators. Recent discoveries of rogue black holes. One of the most fascinating discoveries in recent years came in 2022, when researchers found a free-floating black hole moving through the Milky Way. Unlike black holes anchored in binary systems, this one was alone, drifting through space at 160,000 km/h. The detection was made possible through gravitational microlensing, a technique that observes how light bends around massive objects. This rogue black hole was estimated to be about 7 times the mass of our Sun, confirming that these celestial assassins are not just theoretical, they exist. Another rogue black hole was discovered wandering in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. Scientists believe that when galaxies merge or undergo gravitational disturbances, black holes can be ejected into space, left to drift indefinitely. If these black holes can exist in other galaxies, then the Milky Way almost certainly harbors thousands of them, possibly heading in our direction. Could a black hole ever threaten Earth? The likelihood of a black hole directly colliding with Earth is extremely low, but that doesn't mean we're entirely safe. Even if a black hole doesn't come into direct contact with our solar system, its gravitational influence could still be disastrous. If a rogue black hole passed within a few light years of our Sun, it could disrupt the Oort cloud, the distant shell of icy objects surrounding our solar system. This could send a barrage of comets and asteroids hurtling toward Earth, significantly increasing the risk of an impact event. Some scientists also theorize that dark matter interactions with black holes could influence their trajectories, possibly guiding them toward denser star systems like ours. While this remains speculative, the idea that unseen forces could be moving black holes through the Milky Way is a sobering thought. A galaxy full of cosmic monsters, the Milky Way is not a peaceful place. At its core lies a supermassive black hole capable of consuming entire star systems. Scattered throughout its spiral arms are millions of stellar mass black holes, most of them unseen, drifting through the galaxy like cosmic ghosts. Some are ejected at high velocities, traveling freely through space, while others remain anchored within ancient star clusters, quietly feeding on matter. The discoveries of recent years have shattered the illusion that black holes are rare, distant phenomena. They are far more common than once believed, and some of them are much closer than we ever expected. As astronomers continue to refine their methods for detecting these elusive objects, we may soon discover that our galaxy is teeming with unseen cosmic threats, far more numerous than we ever imagined. If Sagittarius A* were to awaken, if a rogue black hole passed close to our solar system, or if hidden black holes began interacting with dark matter in ways we don't yet understand, the consequences could be beyond anything humanity has ever faced. For now, all we can do is watch the night sky and wait for the next great discovery, one that might change everything we know about the dangers hidden in the Milky Way. Rogue planets, invisible, cold, and deadly. What are rogue planets? The universe is filled with countless planets orbiting stars, much like Earth orbits the Sun. But not all planets belong to a solar system. Some wander through the cosmos, untethered, completely alone. These are known as rogue planets, free-floating worlds that have no home, no parent star, and no stable orbit. Instead, they drift through space, cold and invisible, moving unpredictably through the galaxy. Scientists believe these rogue planets were once part of planetary systems, much like our own, but were violently ejected due to gravitational interactions. A larger planet or a passing star could have disrupted their orbit, flinging them into the darkness. Others may have formed independently in space, never bound to a star in the first place. Unlike planets that orbit stars, rogue planets have no source of heat or light. They exist in eternal night, their surfaces frozen, their atmospheres, if they have any, slowly escaping into space. Because they emit no light, they are nearly impossible to detect. The only way scientists can find them is through gravitational microlensing, a phenomenon where a rogue planet passes in front of a distant star, bending its light like a magnifying glass. Even with advanced technology, we have only just begun to uncover how many of these planetary nomads exist. How many rogue planets exist in the Milky Way? The number of rogue planets in the Milky Way is staggering. Scientists estimate that for every star in our galaxy, there may be at least one rogue planet. That means the Milky Way could contain billions or even trillions of these lonely wanderers, moving unseen through the darkness. In 2021, NASA's Nancy Grace Roman Space Telescope detected the smallest rogue planet ever observed, roughly the size of Mars. But this was just one in a sea of countless others. A groundbreaking study suggested that rogue planets could outnumber stars in our galaxy by a factor of 2 or more. That means for every star we see in the night sky, there could be multiple rogue planets lurking in the void, completely undetectable unless they happen to pass in front of a distant light source. But what happens if one of these rogue planets strays too close to our solar system? Could Earth be in danger from one of these wandering giants? What if a rogue planet approached Earth? The idea of a rogue planet passing near Earth may sound like science fiction, but it is a very real possibility. Because these planets are invisible in the darkness of space, we wouldn't see one coming until it was too late. Unlike asteroids or comets, rogue planets are massive enough to cause devastation without even making direct impact. If a rogue planet entered our solar system, its gravity would disrupt the delicate balance of planetary orbits. The first victims would likely be the outer planets, Neptune, Uranus, or even Saturn. If the rogue planet's trajectory passed close enough, it could send these gas giants drifting off their normal paths, altering the entire structure of our solar system. Even if the rogue planet never came close to Earth, its gravitational influence could pull asteroids from the Kuiper belt or Oort cloud, sending them hurtling toward the inner planets. This would create a chain reaction of cosmic collisions, dramatically increasing the likelihood of an extinction-level impact event. But what if a rogue planet actually passed near Earth? The consequences would be catastrophic. The gravitational pull of such a planet could destabilize our orbit, shifting Earth slightly closer or farther from the Sun. A small shift inward could result in runaway global warming, while a slight outward shift could trigger a new ice age. The rogue planet's gravity could also disrupt tides, causing massive tsunamis, earthquakes, and unprecedented climate chaos. Even without a direct collision, a rogue planet's mere presence in our solar system could spell disaster. And if one ever got close enough, it could pull Earth from its orbit entirely, flinging our planet into deep space, a frozen, lifeless rock drifting endlessly through the void. The search for rogue planets. Because rogue planets emit no light, they remain one of the greatest mysteries of the Milky Way. However, recent breakthroughs in gravitational microlensing have allowed astronomers to catch glimpses of these elusive worlds. One of the most significant discoveries came in 2020, when scientists using the OGLE, optical gravitational lensing experiment, telescope found a rogue planet roughly the size of Earth. This was the first time a planet so small and isolated had been detected outside a solar system. The discovery confirmed that rogue planets come in all sizes, not just massive gas giants, but Earth-like worlds as well. Another study using NASA's Kepler Space Telescope found strong evidence that our galaxy is filled with rogue planets. Kepler observed unexpected dimming of stars, suggesting that large, unseen objects were passing between Earth and distant stars. The results indicated that there could be hundreds of billions of rogue planets drifting through the Milky Way, unseen and unpredictable. Could rogue planets harbor alien life? At first glance, a rogue planet seems like the last place life could exist. Without a star, these planets are completely frozen, with surface temperatures dropping to extreme levels. But deep beneath their icy exteriors, some rogue planets may actually be habitable. Scientists believe that rogue planets with thick atmospheres or subsurface oceans could maintain liquid water, even in deep space. The key is geothermal heating, the same process that keeps the oceans beneath Jupiter's moon Europa or Saturn's moon Enceladus from freezing solid. A rogue planet with a dense hydrogen atmosphere could trap enough heat to sustain microbial life, even without sunlight. Some theories suggest that these planets could act as lifeboats for life, preserving organisms that originated in a star system before being ejected into space. In other words, if alien life exists on these planets, it may have adapted to survive in total darkness, thriving in underground lakes or hydrothermal vents. The idea that life could exist independent of a star is one of the most fascinating concepts in astrobiology. It raises the question: could rogue planets be carrying alien life forms across the galaxy, waiting to be discovered? The silent threat drifting through the Milky Way. Rogue planets are among the most mysterious and unpredictable objects in our galaxy. Unlike asteroids, comets, or even black holes, they move without warning, undetectable until they pass between us and a distant star. Their sheer number, potentially outnumbering stars themselves, means that at any given moment, one could be passing through the Milky Way, completely unnoticed. The danger is not just in their existence but in our inability to track them. Without light, rogue planets remain hidden in the cosmic darkness, a silent, invisible threat that could one day drift too close to Earth. If one were on a collision course with our solar system, we might not see it coming until it was far too late to stop it. As scientists continue to refine their detection methods, the hope is that we will uncover more about these wandering worlds before one of them uncovers us. Until then, rogue planets remain one of the greatest unknown dangers of the Milky Way, silent predators moving unseen through the dark. Gamma-ray bursts, cosmic death rays. What are gamma-ray bursts? Deep in the cosmos, the most powerful explosions in the universe occur without warning. Gamma-ray bursts, or GRBs, unleash energy so intense that a single burst can outshine an entire galaxy. These cosmic death rays emit more energy in seconds than the Sun will produce in its entire 10 billion year lifetime. If one were to strike Earth, the consequences would be nothing short of catastrophic. Gamma-ray bursts originate from two primary sources: the death of massive stars and the collision of neutron stars. When a supermassive star runs out of fuel, it collapses in on itself, triggering a hypernova explosion. This event generates jets of gamma radiation, traveling at nearly the speed of light, capable of obliterating anything in their path. The second major cause of GRBs is the merger of neutron stars. Neutron stars are the ultra-dense remnants of exploded supernovae, each packing more than 1.4 times the Sun's mass into a sphere no larger than a city. When two of these stellar corpses collide, the impact releases a flood of gamma rays, sending deadly radiation across the universe. These explosions don't just happen in distant galaxies. Some GRBs originate within the Milky Way, raising the terrifying question: could one of these cosmic death rays be heading toward Earth? The deadly reach of GRBs is one of the most alarming facts about gamma-ray bursts is their ability to devastate planets light years away. Unlike supernovae, which primarily affect their immediate surroundings, GRBs are directional, shooting concentrated beams of high-energy radiation across vast distances. If Earth were caught in the crosshairs of even a moderately close GRB, the results would be catastrophic. A GRB aimed at Earth could strip away our ozone layer, leaving the planet defenseless against deadly ultraviolet radiation from the Sun. Without this protective shield, UV rays would sterilize the surface, exterminating plants, marine life, and land-based species. The long-term effects could mirror a nuclear winter, with radiation-induced mutations, widespread extinctions, and the collapse of the food chain. Some scientists believe that a past GRB might have been responsible for one of Earth's mass extinctions. While no direct evidence has confirmed this theory, researchers suggest that the Ordovician-Silurian extinction, which wiped out 85% of marine species 443 million years ago, may have been triggered by a gamma-ray burst. If a similar event were to occur today, humanity's survival would be uncertain. Has Earth ever been hit by a GRB? Although no modern civilization has witnessed a GRB strike firsthand, there is strong evidence that Earth has been hit before. One of the most intriguing clues comes from the carbon-14 spike in 774 AD. Researchers analyzing tree rings found an unexplained surge of carbon-14 isotopes, a phenomenon that typically results from exposure to high-energy cosmic radiation. Theories suggest that this radiation surge may have been caused by a nearby gamma-ray burst or a massive solar event. While the 774 AD event was not strong enough to cause mass extinction, it raises an unsettling question. If a mild burst could alter Earth's atmospheric chemistry, what would happen if a more powerful one struck? Given the immense energy GRBs release, an event 10 times stronger could leave Earth uninhabitable. The real danger lies in the potential candidates for future GRBs within the Milky Way. Astronomers have identified several massive stars nearing the end of their life cycle, any of which could trigger a hypernova capable of producing a deadly burst. One such candidate is WR104, a Wolf-Rayet star located only 8,000 light-years away. This star has already entered its final stages and, if it collapses in the right orientation, could send a gamma-ray beam directly toward Earth. The most dangerous GRBs ever recorded. Even though most GRBs occur in distant galaxies, the ones we have observed reveal just how terrifying they truly are. In 2019, astronomers detected a record-breaking GRB that released more energy in a few seconds than our Sun will emit in 10 billion years. This single explosion, detected 7 billion light-years away, was so powerful that its radiation briefly affected Earth's ionosphere, even at such an extreme distance. Another notable event occurred in 2004, when a gamma-ray burst from SGR 180620, a magnetar located 50,000 light-years away, briefly ionized Earth's atmosphere. Even though this GRB was on the opposite side of the galaxy, it still had measurable effects on our planet. Had it been 10 times closer, it could have caused widespread damage. Perhaps the most disturbing discovery came in 2022, when astronomers observed a GRB so bright that it was initially mistaken for a new celestial object. Dubbed, BOAT, brightest of all time, this explosion was so intense that it left scientists stunned. Even though it occurred in a galaxy billions of light-years away, the radiation from this event temporarily blinded some of Earth's satellites. If such an explosion had occurred within our galaxy, the consequences would have been devastating. How close would a GRB need to be to harm Earth? Scientists estimate that a gamma-ray burst would need to be within 5,000 to 10,000 light-years to pose a serious threat to Earth. While this distance may seem vast, there are several stars within this range that could potentially produce a GRB. The greatest threat comes from massive stars in their final stages. When a Wolf-Rayet star collapses, it has the potential to emit a GRB directed outward in two beams. If one of these beams were aimed at Earth, the effects could be instantaneous and irreversible. Even a mild GRB at this range could result in atmospheric devastation, altering global climate patterns and causing rapid species extinction. If a stronger GRB were to strike, it could potentially sterilize an entire hemisphere of the planet, leaving only underground or deep-sea life to survive. Could we ever protect ourselves from a GRB? The terrifying reality is that there is no known way to prevent or defend against a gamma-ray burst. Unlike asteroids, which we can track and potentially deflect, GRBs travel at the speed of light, meaning we would have zero warning before impact. By the time we detected a GRB aimed at Earth, the radiation would already have arrived. Some researchers propose that future space technology could allow us to monitor nearby Wolf-Rayet stars more closely, giving us a better understanding of potential threats. However, even if we knew a GRB was coming, there is little humanity could do except seek shelter deep underground. The only real defense against GRBs is distance. As long as we remain fortunate enough that these cosmic explosions occur far from Earth, we will be safe. But as we continue to study the dynamics of dying stars, one thing remains clear: the Milky Way is far from a safe place. Somewhere in the depths of our galaxy, a future gamma-ray burst is waiting to happen, and when it does, the entire cosmos will bear witness. Dark matter, the unknown force holding the galaxy together. But what is dark matter and why is it a mystery? For centuries, scientists have tried to understand what holds the universe together. Gravity, as we know it, explains how stars orbit galaxies and how planets stay in motion. But something is missing from the equation. The universe behaves as though there is a massive, unseen force pulling everything together. A force that accounts for 85% of all matter in the universe but remains completely invisible. This force is known as dark matter. Unlike ordinary matter, dark matter does not emit, absorb, or reflect light, making it impossible to detect through conventional telescopes. Scientists only know it exists because of its gravitational effects. Galaxies spin much faster than they should based on their visible mass alone, and without an additional source of unseen mass, they would simply fly apart. The invisible influence of dark matter keeps galaxies intact, shaping the cosmic web that binds the universe together. Despite decades of research, dark matter remains one of the biggest unsolved mysteries in physics. It could be made of exotic particles that barely interact with normal matter, or it could be something even more bizarre, an entirely new form of physics that we have yet to understand. Some theories suggest that dark matter could be woven into the very fabric of space itself, influencing the motion of galaxies in ways we have yet to comprehend. But as scientists continue to study dark matter, a more unsettling question arises: could this invisible force pose a danger to our galaxy, and to Earth? Could dark matter be dangerous? Most discussions about dark matter focus on its role in holding galaxies together, but some scientists believe it may have a more destructive side. Since dark matter interacts almost exclusively through gravity, its presence could lead to cataclysmic cosmic events that we have yet to witness or understand. One of the more chilling theories involves dark matter bullets, invisible, high-speed clusters of dark matter moving through space. These dense concentrations of dark matter could be traveling across the universe at incredible speeds, and if one were to pass through our solar system, the gravitational disturbance could be catastrophic. The movement of a dark matter bullet could disrupt planetary orbits, pull asteroids out of their stable positions, or even destabilize the Sun's gravitational balance, creating long-term changes to Earth's climate. Another theory suggests that dark matter could be influencing the growth of black holes. Since black holes feed on surrounding matter, dark matter could act as a gravitational fuel source, accelerating their expansion far beyond what current models predict. If this is true, then some black holes may be far larger and more dangerous than we realize, and they could be growing at an alarming rate due to the invisible presence of dark matter. The Bullet Cluster, proof of dark matter collision, one of the most compelling pieces of evidence for dark matter's existence comes from a cosmic event known as the Bullet Cluster. Located 3.8 billion light-years away, this violent collision between two galaxy clusters provided the first direct proof that dark matter is real. When astronomers observed the aftermath of this collision, they noticed something strange. The visible matter in the two clusters did not align with their gravitational effects. Instead, most of the mass appeared to be in regions with no visible light, indicating that a huge portion of the mass was completely invisible. This invisible force was identified as dark matter, and its gravitational pull remained completely unaffected by the violent destruction of galaxies. But what if similar collisions have happened, or will happen, within the Milky Way? If dark matter can move independently of regular matter, then high-density streams of dark matter could be passing through our galaxy right now, completely undetectable, yet capable of influencing massive celestial events. Could dark matter be disrupting spacetime? Another disturbing theory suggests that dark matter may not just be influencing gravity, it may be actively warping the structure of spacetime itself. Some physicists believe that dense regions of dark matter could be creating small distortions in the fabric of reality, similar to how black holes bend space around them. If true, these distortions could have unexpected consequences. One possibility is that dark matter could alter the passage of time itself, slowing or speeding up certain regions of space without us realizing it. Some scientists even propose that dark matter accumulations could be responsible for unexplained cosmic phenomena, such as the disappearance of stars or the strange behavior of distant galaxies. While these ideas remain speculative, the possibility that dark matter could be shaping space-time in ways we do not yet understand makes it one of the most intriguing and unsettling forces in the universe. How close is dark matter to Earth? Dark matter isn't just out there in deep space, it exists everywhere, including right here in our own galaxy. In fact, scientists believe that dark matter forms a halo around the Milky Way, surrounding us in an invisible cloud of unknown material. Because dark matter does not interact with normal matter, it could be passing through Earth right now without us even noticing. Some experiments suggest that dark matter particles may occasionally collide with atoms on Earth, producing minuscule bursts of energy. If these interactions are happening, they could provide the first direct evidence of dark matter's presence. But what if dark matter isn't as harmless as we assume? If dense concentrations of dark matter exist within the Milky Way, their gravitational influence could be affecting planetary orbits, altering star formations, or even playing a role in cosmic extinction events. Some theories even suggest that dark matter disturbances could be responsible for unexplained asteroid movements, possibly triggering mass extinctions in Earth's past. The future of dark matter research. The search for dark matter is one of the most ambitious scientific quests of our time. Physicists have built underground laboratories, space telescopes, and massive particle detectors to hunt for traces of this invisible force. One of the most promising experiments, the Xenon dark matter detector, is buried 1,400 meters beneath the Earth's surface in Italy. Scientists working on this project hope to detect rare interactions between dark matter and normal matter, finally proving its existence beyond gravitational effects. Other researchers are using cosmic observations to map the distribution of dark matter throughout the universe, attempting to understand its role in galactic evolution and the formation of cosmic structures. If dark matter truly does influence black hole growth, planetary movement, or the stability of our solar system, then discovering its nature could be crucial for understanding the long-term future of Earth and the Milky Way. The invisible threat of the universe. Dark matter is the greatest mystery of modern astrophysics. It holds galaxies together, influences the movement of stars, and may even play a role in shaping the universe's fundamental structure. But as we continue to uncover its secrets, new questions arise. Is dark matter as passive as we believe, or could it be far more dangerous than we ever imagined? From the terrifying possibility of dark matter bullets tearing through space to the idea that hidden accumulations of dark matter could trigger black hole growth, one thing is clear: we still know almost nothing about this invisible force. For now, dark matter remains an unseen giant, shaping our galaxy in ways we are only beginning to understand. But as technology advances and our knowledge deepens, we may soon uncover whether dark matter is a silent guardian of the universe, or a hidden force of destruction waiting to be revealed. Supernova explosions, our galactic time bombs. How often do supernovae occur in the Milky Way? The Milky Way is home to hundreds of billions of stars, and many of them are ticking time bombs. A supernova explosion occurs when a massive star reaches the end of its life, collapsing under its own gravity before erupting in an explosion so powerful it can outshine an entire galaxy for weeks. These explosions release an enormous amount of radiation and high-energy particles, capable of altering planetary atmospheres and even causing mass extinctions. Scientists estimate that a supernova occurs in the Milky Way every 50 years on average, meaning there should have been at least a dozen explosions in the last 1,000 years alone. However, because many supernovae occur on the far side of the galaxy, hidden by cosmic dust, we often miss them. The last visible supernova in the Milky Way was Kepler's supernova, which exploded in 1604 and was bright enough to be seen during the day for weeks. Although most supernovae occur safely thousands of light years away, astronomers have long wondered, what if one were close enough to affect Earth? Could a nearby supernova pose a threat to life? The supernova kill zone, how close is too close? Not all supernovae are dangerous to Earth, but there is a kill zone, a specific range within which a supernova could devastate our planet's atmosphere. Scientists estimate that if a supernova explodes within 50 light-years of Earth, the radiation and cosmic rays could destroy our ozone layer, exposing the surface to deadly levels of ultraviolet radiation from the sun. The effects wouldn't be instant, but they would be catastrophic over time. The loss of the ozone layer would allow unfiltered UV rays to bombard the planet, leading to widespread cancer, genetic mutations, and massive disruptions to ecosystems. The food chain would collapse as plant life and plankton, the foundation of Earth's biological system, suffer irreparable damage. Fortunately, no known stars capable of producing a supernova are that close to Earth. However, some dangerously close candidates exist. The most famous of them is Betelgeuse, a red supergiant in the constellation Orion, located about 642 light-years away. While it's well outside the 50 light-year kill zone, it is still one of the closest supernova candidates in our cosmic neighborhood. What would happen if Betelgeuse exploded? Betelgeuse is nearing the final stages of its life, and scientists believe it could explode at any time within the next 100,000 years. When it does, it will unleash a blinding flash of energy, making it one of the brightest objects in the night sky. Although Betelgeuse is too far to physically harm Earth, the explosion will release a massive burst of gamma rays and cosmic radiation. If a supernova of this magnitude occurred significantly closer, the radiation would cause long-term damage to Earth's atmosphere, similar to a nuclear winter. Betelgeuse isn't the only nearby star on the verge of explosion. Antares, another red supergiant, sits 550 light-years away, while Spica, a blue giant, is just 260 light-years from Earth. If one of these stars were much closer, the results could be devastating. Has a supernova ever affected Earth? The idea that a supernova could influence Earth's history is not just speculation. There is actual evidence that past supernovae have already impacted our planet. Scientists have discovered iron-60 isotopes in deep sea crusts, a rare form of iron that is only produced in supernova explosions. These isotopes suggest that at least one supernova explosion occurred within 300 light-years of Earth between 2 and 3 million years ago. This timeline coincides with the Pliocene-Pleistocene boundary, a period of major climate change that led to the extinction of several prehistoric species. Some researchers believe that a nearby supernova may have triggered an ice age, altering the course of evolution on Earth. More recently, scientists detected iron-60 deposits in Antarctic snow, suggesting that supernova debris is still reaching Earth today. This means that supernova remnants from past explosions are constantly bombarding our planet, though at levels that are not yet considered dangerous. Could a supernova in the future threaten Earth? While we may not see a dangerously close supernova in our lifetime, the long-term threat remains. New stars are constantly being born, and some will inevitably reach the end of their life cycles in ways that could impact our planet. One potential threat comes from binary star systems, where two stars orbit each other. If one of these stars is a white dwarf, it can slowly accumulate material from its companion star. When it reaches a critical mass, it can trigger a Type Ia supernova, an explosion so powerful it can radiate across the galaxy. If such an explosion occurred within 100 light-years of Earth, it could flood our planet with deadly radiation, causing long-term climate shifts and wiping out entire ecosystems. Some researchers also speculate that long-duration gamma-ray bursts, GRBs, from supernovae could be even more dangerous than the explosion itself. If a GRB were aimed directly at Earth, the radiation could strip the atmosphere, leading to a global extinction event. What would we see if a supernova happened nearby? If a supernova exploded within 100 light-years, it would be brighter than the full moon and visible during the day. For weeks, it would dominate the night sky, outshining every other celestial object. Beyond its brightness, the supernova's radiation could trigger auroras far beyond the usual polar regions, creating dazzling light shows across the planet. However, the more concerning effects, atmospheric damage and radiation exposure, would take months or years to fully develop. If scientists detected a nearby supernova candidate in its final stages, would there be anything we could do? The truth is, we would be powerless to stop it. Unlike asteroid impacts, which we can track and possibly deflect, a supernova explosion is unstoppable. Our best hope would be underground shelters or artificial habitats shielded from cosmic radiation. Are we safe from the next supernova? For now, the closest supernova candidates are still hundreds of light years away, meaning that Earth is safe from direct supernova destruction. However, our galaxy is vast, and new stars are constantly evolving. A new supernova threat could emerge at any time, from an unknown star that has yet to be fully studied. The biggest challenge is tracking potential supernova explosions before they happen. Astronomers use X-ray and gamma-ray telescopes to monitor stars in their final stages, but predicting the exact moment of a supernova is nearly impossible. One day, a star could explode without warning, sending a burst of radiation across the galaxy. The Milky Way is not a safe place. It is an ever-changing battlefield of exploding stars, cosmic radiation, and high-energy particles. While we may be safe from a supernova for now, the next great explosion could be closer than we think. Until then, all we can do is watch the stars and hope that the next cosmic detonation remains at a safe distance from our fragile planet. The Great Galactic Collision, the future apocalypse, the Milky Way and Andromeda, a cosmic collision course. The universe is in constant motion. Every star, planet, and galaxy is drifting through the vastness of space, guided by gravity and cosmic forces. But sometimes, these celestial objects don't just drift, they collide. That is exactly what will happen to the Milky Way and Andromeda galaxies in the distant future. Right now, Andromeda, the nearest major galaxy to the Milky Way, is hurtling toward us at a speed of 110 kilometers per second. This means that, in approximately 4.5 billion years, the two galaxies will collide, merging into a single, massive galactic system. The event will be unlike anything humanity, or even the Earth, has ever experienced. It will reshape the structure of our galaxy, sending billions of stars into new orbits, forming new star systems, and possibly altering the fate of our solar system forever. Galactic collisions are not rare. In fact, astronomers have observed numerous galaxies in the process of merging, and the aftermath is always chaotic. The Milky galaxy, a term coined by scientists, is the name given to the future merged form of the Milky Way and Andromeda. But before this new galaxy takes shape, there will be millions of years of cosmic upheaval. What happens when two galaxies merge? At first glance, a galactic collision might sound like an apocalyptic event where stars crash into each other like wrecking balls. However, due to the immense distances between stars, direct star-to-star collisions are incredibly rare. Instead, the gravity of each galaxy will stretch, twist, and warp their respective shapes, distorting their beautiful spiral arms and creating massive tidal waves of star formation. As the two galaxies interact, Andromeda will begin to rip apart the Milky Way, pulling billions of stars into new gravitational paths. Some stars will be flung into intergalactic space, becoming homeless wanderers in the void, while others will be pulled into dense, chaotic regions where they may be consumed by black holes or crushed into new planetary systems. Over time, the two galaxies will fully merge, forming a massive elliptical galaxy with little resemblance to either the Milky Way or Andromeda. But before that happens, there will be a long period of instability, during which our solar system may be at risk. What happens to Earth during the collision? One of the biggest questions surrounding the Milky Way Andromeda collision is whether Earth will survive. The answer isn't entirely clear, but scientists have run detailed simulations to predict what will happen. One possible outcome is that our solar system remains largely unaffected. Since space is mostly empty, the chances of another star passing close enough to disrupt our orbit are relatively low. However, there is still a small but real chance that the gravity of Andromeda will send Earth and our entire solar system drifting away from the galaxy, ejecting us into deep space. If this happens, Earth would lose its connection to the Milky Way, drifting as a rogue planetary system with no galactic home. The long-term survival of the planet would depend on how much of our solar radiation remains intact, but it could mean eternal darkness and extreme cold if we were pulled too far from other sources of light. Even if Earth remains inside the newly formed Andromeda galaxy, the violent cosmic reshuffling could lead to gravitational disturbances that affect planetary orbits. If our sun's path is altered, even slightly, it could result in dramatic climate changes, pulling Earth closer to the sun and triggering a runaway greenhouse effect, or farther away, plunging the planet into a deep freeze. Another major concern is the collision of supermassive black holes. Both the Milky Way and Andromeda contain enormous black holes at their centers. When these giants collide, they will release an unimaginable amount of gravitational waves, which could alter the fabric of space-time. Although Earth is far from the galactic center, the sheer force of this merger could send shockwaves through space, disrupting planetary systems on a scale we have never seen before. Simulations of galactic collision. Astronomers have used powerful supercomputers to simulate what will happen when the Milky Way and Andromeda collide. These simulations reveal a multi-stage process that will take billions of years to fully unfold. The first phase occurs when Andromeda makes its initial approach. As it nears, the gravitational pull between the two galaxies stretches their spiral arms, distorting their once distinct shapes. Over the next few million years, the two galaxies will pass through each other, momentarily forming an elongated, chaotic structure. This will trigger a massive burst of star formation, as gas clouds collide and collapse, igniting the birth of thousands of new stars. During the second phase, the two galaxies will become gravitationally bound, orbiting around a common center while still distorting each other. Their individual spiral structures will continue to unravel, and smaller star clusters will begin to merge. Finally, after millions of years of this cosmic dance, the two galaxies will completely fuse, forming a new elliptical galaxy. The beautiful spiral structure of the Milky Way will be gone forever, replaced by a featureless, rounded mass of stars and cosmic debris. How have other galaxies survived mergers? Galactic collisions are not just a future event for the Milky Way, they have been happening since the dawn of the universe. In fact, astronomers have observed several ongoing galactic mergers, giving us a glimpse into what our own future might look like. One of the most well-known examples is the Antennae galaxies, a pair of colliding galaxies 45 million light-years away. These galaxies are in the middle of their merger, their spiral arms stretched into long, glowing tendrils as new stars form in the aftermath of the collision. This process gives us an idea of what the Milky Way and Andromeda may look like millions of years after their initial encounter. Another example is NGC 6240, a chaotic galaxy that formed from a collision between two smaller galaxies. Astronomers have observed its two central black holes moving toward each other, which suggests that eventually, they will merge into one even larger supermassive black hole, much like what will happen when the Milky Way and Andromeda unite. These observations confirm that galactic collisions do not necessarily mean destruction. Instead, they represent a cosmic rebirth, a transformation that reshapes the affected galaxies into something new. The future of our galaxy, the collision of the Milky Way and Andromeda, will mark the end of the galaxy as we know it, but it will also mark the beginning of something new. The Milky galaxy will be larger, brighter, and more densely packed with stars than the Milky Way ever was. But for Earth, the outcome remains uncertain. Will we stay safely within the new galaxy, continuing to orbit the Sun as usual? Or will we be flung into the darkness of intergalactic space, left to drift through the void forever? The only certainty is that the Milky Way's days are numbered. As Andromeda approaches, we are witnessing the final chapters of our galaxy's story, an inevitable cosmic fate that will unfold over billions of years. For now, all we can do is watch and wait, knowing that the greatest transformation in the history of our galaxy is already in motion, a collision that will reshape the Milky Way forever. Could Earth be destroyed by one of these events? Ranking the dangers, which one is most likely to affect us? Throughout this journey into the hidden threats of the Milky Way, we've explored some of the most terrifying cosmic dangers that could threaten Earth. Supermassive black holes, rogue planets, gamma-ray bursts, dark matter anomalies, and supernova explosions, each one a force powerful enough to disrupt life as we know it. But which of these threats is the most immediate, and which ones are long-term dangers that may never come to pass in our lifetime? When ranking cosmic extinction events, we need to consider two key factors: probability and impact. Some dangers, like supernovae and gamma-ray bursts, are relatively rare but could be devastating if they occur close enough. Others, like rogue planets and wandering black holes, are harder to detect, meaning we might not see them coming until it's too late. One of the most immediate dangers comes from gamma-ray bursts, GRBs. These powerful beams of radiation travel at the speed of light, meaning that if one were aimed at Earth, we wouldn't know until it arrived. A GRB within 10,000 light-years could be catastrophic, stripping away Earth's ozone layer and exposing the planet to lethal radiation. While rare, these bursts have happened before. Evidence suggests that a past GRB may have triggered a mass extinction event millions of years ago. Rogue planets pose a different kind of threat. While they wouldn't necessarily destroy Earth outright, they could disrupt the delicate gravitational balance of the solar system. If a rogue planet passed close enough, it could alter Earth's orbit, triggering extreme climate shifts or even ejecting Earth into interstellar space. The problem? Rogue planets are nearly invisible, making them one of the most unpredictable threats in our galaxy. Wandering black holes, though terrifying in theory, are less likely to pose an immediate threat. The probability of a rogue black hole passing close enough to Earth to cause destruction is extremely low. However, if one did approach, its gravitational pull could be catastrophic, disrupting planetary orbits, altering the Sun's position, or even consuming parts of the solar system entirely. Finally, supernova explosions, while spectacular, would need to occur within 50 light-years to pose a serious risk to Earth. So far, no known supernova candidates are close enough to cause an extinction-level event, though scientists continue to monitor nearby stars for potential explosions. Could humans ever prevent these disasters? With threats ranging from invisible rogue planets to radiation bursts traveling at light speed, the question arises, could we ever defend Earth against a cosmic disaster? Science fiction often presents scenarios where humanity builds advanced planetary shields, gravity-manipulating technology, or even planetary engines that allow us to relocate Earth itself. But how close are we to real-world solutions? Right now, planetary defense is mostly focused on asteroid impacts. NASA and other space agencies have developed programs to detect and track near-Earth objects, with plans in place to deflect or destroy potential threats. The recent DART, Double Asteroid Redirection Test, mission proved that it's possible to alter the trajectory of an asteroid by slamming a spacecraft into it. But what about larger, more complex threats? For gamma-ray bursts, the challenge is that we cannot stop them. Since GRBs travel at light speed, there is no way to predict their arrival, nor would we have time to react. The only viable strategy would be to develop underground or deep-sea shelters, allowing humanity to survive until the radiation levels subside. If a rogue planet were approaching Earth, we would need an entirely different strategy. Some scientists have proposed using gravity tractors, large spacecraft that hover near an object and use gravitational forces to slowly alter its path. While this method could work for asteroids, it is highly unlikely that we could shift the trajectory of an entire rogue planet. Instead, humanity's best option might be leaving Earth behind, using massive spacecraft to relocate to another world before disaster strikes. For a wandering black hole, there would be no escape. If one were heading toward our solar system, the only possible hope would be to develop spacefaring technology capable of interstellar travel, allowing a portion of humanity to escape before gravitational forces became too strong. One of the most ambitious ideas comes from theoretical physicist Michio Kaku, who suggests that an advanced civilization could one day move entire planets by using giant fusion-powered thrusters to shift their position over time. This concept, known as a stellar engine, could theoretically allow Earth to escape a dangerous region of space or move away from an impending galactic collision. However, this idea is millions of years beyond our current technological capabilities. How realistic are sci-fi solutions? Science fiction often imagines far-fetched solutions to cosmic disasters, from artificial wormholes to force fields capable of deflecting cosmic radiation. But are any of these ideas based on real physics? Some concepts, like space-based solar shields, are actually being studied. Scientists have proposed building large-scale structures in orbit that could block or deflect dangerous radiation from space. These could serve as artificial ozone layers, shielding Earth from gamma-ray bursts or supernova radiation. Another idea gaining traction is terraforming Mars or other planets as a backup in case Earth becomes uninhabitable. If a long-term space threat emerged, such as a rogue planet disrupting Earth's orbit, having a secondary home for humanity could be crucial for survival. Companies like SpaceX and NASA are already working toward this goal, with plans to establish permanent human settlements on Mars within the next century. One of the most radical ideas is building an interstellar ark, a massive spaceship designed to carry millions of humans to a new star system. Theoretically, if Earth were threatened by an unstoppable cosmic event, such as a black hole or gamma-ray burst, humanity could board these spacecraft and search for a new home in the stars. While such technology is far beyond our current reach, scientists have already begun considering how such missions could work in the future. Can Earth survive the next cosmic disaster? While the universe is filled with dangers, it is also incredibly vast. The likelihood of any single cosmic disaster wiping out Earth within our lifetime is extremely low. However, as our civilization advances, it is crucial to study these threats and develop strategies for long-term survival. The good news is that space agencies worldwide are actively monitoring cosmic threats. The development of advanced telescopes, planetary defense programs, and space exploration technology will help us better understand and possibly predict future dangers. For now, humanity's best hope lies in expanding beyond Earth. As we continue to explore Mars, the Moon, and distant exoplanets, the dream of becoming a multi-planetary species grows closer. If we succeed in establishing permanent human colonies beyond Earth, it would be the greatest insurance policy against cosmic extinction. While the Milky Way remains a beautiful yet dangerous place, Earth has survived billions of years of cosmic events, and with continued advancements in science and space exploration, we may ensure that our planet and our species endure for billions more. The Milky Way is far from a peaceful place. As we've explored the hidden dangers of our galaxy, one thing has become abundantly clear: the Milky Way is not a safe place. While our solar system may seem like a stable and predictable environment, the cosmic forces at play tell a different story. Beyond our sky, supermassive black holes lurk, ready to consume anything that strays too close. Rogue planets drift through space, invisible and unpredictable, capable of disrupting entire solar systems. Gamma-ray bursts unleash the most powerful energy blasts in the universe, threatening to wipe out life in an instant. Dark matter, the unseen force shaping our galaxy, remains one of the greatest mysteries of modern physics. And if that weren't enough, supernova explosions and the inevitable collision of the Milky Way and Andromeda remind us that nothing in the cosmos lasts forever. Are we safe, or is it just a matter of time? The reality is both reassuring and unsettling. On one hand, many of these cosmic disasters occur on timescales far beyond human lifetimes. The Milky Way-Andromeda collision won't happen for another 4.5 billion years, and most supernova candidates are too far away to pose a serious risk. But other threats, like rogue planets, gamma-ray bursts, and black holes, could emerge without warning, leaving us little time to prepare. Our current technology allows us to detect some cosmic threats, We can track asteroids, study dying stars, and analyze cosmic radiation. However, many dangers remain unseen, lurking beyond our ability to predict or prevent them. The universe doesn't operate on human timescales, and while Earth has survived billions of years, there's no guarantee that it will remain untouched forever. The best chance for humanity's survival lies in space exploration and scientific advancement. As we expand our reach beyond Earth, developing off-world colonies and deep space observation technology, we increase our odds of detecting and potentially mitigating cosmic threats. The better we understand the universe, the better we can prepare for what's to come. What comes next? The Milky Way is a beautiful but chaotic place, filled with wonders and dangers beyond imagination. While we may not know exactly when or where the next cosmic event will strike, one thing is certain: the universe is always in motion, and change is inevitable. So, the question remains: are we truly safe, or is it only a matter of time before one of these cosmic threats finds us? If this journey through the dark side of the Milky Way has left you fascinated, there's so much more to explore. Stay informed, stay curious, and keep looking up at the vast, unpredictable cosmos that surrounds us. If you found this mind-blowing, subscribe for more deep dives into the mysteries of space, science, and the unknown. There's still so much we don't know about the universe, and together, we'll uncover the secrets hidden in the stars.